This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to episode number 21. So how you doing, Kaushik?
I am doing good. How are you, Donn?
Doing good. You know, it's fall over here. My backyard is like a montage to Ned Stark's "Winter is Coming" memes.
Oh wow, that's pretty cool.
So, the leaves are falling. I literally feel like I'm in the middle of Game of Thrones over here in the hills of New Jersey. So everything is going good.
Nice. You know, one thing that always frustrates me about the Game of Thrones "Winter is Coming" thing.
What?
We never get to see Game of Thrones in winter here.
Yeah, you never do you? That's true.
Winter is coming, but then you actually do see Game of Thrones only in April, which kind of makes it a bummer.
It does. All the snow's kind of melted by then. Unless you live in Minnesota, then it's still snowing. Maybe that's the point. Yeah. When we left Minnesota in 2011, May 5th, it was snowing and I had the snowblower out. So that was a little wild.
What? How was Halloween for you?
That's funny. I was going to bring that up. Small story about that. I was very last minute in helping my kids get costumes this year, and we went to a little Halloween store next to our house, found them stuff, and then all of a sudden I realized, like, hit me. I was like, I just want to wear a banana suit for Halloween. And I told my wife,
urge to be a banana.
I told my wife, I want to be a banana, I want to wear a banana suit. And she just looked at me like, what the? And we asked the guy and they didn't have any. And I was kind of disappointed. I was like, this is a perfect opportunity to wear a banana suit for no reason. And so she was excited they didn't have it. And so I went home and of course checked on Amazon and found that I could get one for $20 and I had Amazon Prime and it would be there before Halloween. So What did I do? I ordered a banana suit and it got there 3:00 on Halloween and I went trick-or-treating with my kids wearing a banana suit.
Okay. Did you have more fun than them, Donn? Looks like it.
I might have had the equivalent or more fun. It was kind of interesting because, I'm 6'4", and then the top of the banana goes like another 1.5 feet above me. And so my wife was looking at me like, what the heck are you doing? Like this 8-foot banana walking down the road.
You probably scared everyone away. How much candy did your kids get?
I got a lot,
Oh, okay. So it worked then.
Yeah, but every little kid would be like, hey, it's the banana. And then all of a sudden they would go instantly into minion voice and go, banana, banana, banana.
Oh, that sounds like a lot of fun.
So it was good. How was yours?
Mine was good. So our whole team at Instacart, we decided we'll replicate Star Wars and all of us dressed up as Star Wars characters.
Oh, nice.
Yeah, so I went with the tried and trusty Stormtrooper. So I dressed up as a Stormtrooper. It was a lot of fun.
That's awesome. So were you a Stormtrooper on the train?
Oh, no, I didn't. I took my costume there and I changed midway because...
That would have been awesome, just rolling down the streets of San Francisco as a Stormtrooper.
I would have probably done that, but I guess it was in the BART. If you're dressed up, if you attract a lot of attention, sometimes... That's not always the best thing. So you want to keep it sort of calm.
Yeah, weird things can happen that way. Cool. So we do have a couple of housekeeping items to bring up. One was a lot of people have asked, about how they can send in recommendations. And we mentioned this before, but if you do have a recommendation for what you would like to hear on the show, you can go to fragmentedpodcast.com/contact. It's just a little contact form there. Fill out the information of, hey, we'd like to hear more about X, Y, and Z, and that will go both to Kaushik and I, and we can check it out. I'd like to also say thanks to all the people that have sent in recommendations already. We're getting a ton of good ideas for future episodes coming forward, so thank you very much. Secondly, I will be at AndoridTO, which is Android Toronto, on December 1st. Come on out. It's basically a one-day little Android DevFest conference in Toronto. Myself, as well as Jake Wharton and a bunch of other great speakers are going to be there. So looking forward to seeing you there if you're in the area on December 1st in Toronto.
Very cool.
So we got a bunch of good feedback on the Kotlin episode, wouldn't you say?
Oh, absolutely. People have been coming back with some great feedback on Kotlin. Hadi was, as usual, amazing. He had some great things to say. And Kotlin also went live with their beta. So it's like a 1.0 beta. So that timing worked out pretty well.
It did. And I recently tweeted this, but I'll mention it here, that Don't forget, like if you're interested in trying out Kotlin, because it does have a lot of really cool features that make developing a lot more pleasurable than traditional Java 6. If you want to try it out, you don't have to just pretty much switch over and whole hog your entire app. You can basically just use it for a part of your app. So maybe you just want to kind of create a screen, or you want to use the data access piece, or just one little component just to try out Kotlin. You can do that inside of your existing app. So no need to worry about, switching everything over to Kotlin. You can kind of piecemeal it together.
And another thing is Google has come out with Google Play Music podcast. So if you've been following the news, they are planning to enter the podcast scene, which is good usually for everyone. And we want to let listeners know that we have already submitted and we will be on Google Play Music. So if you know anyone who for some strange reason feels that the only way they'll listen to podcasts is with the Google Play Music app and not anything else, well, then we are on Google Play Music. So folks can enjoy the podcast on that.
Definitely. So what are we going to talk about today? Do you know?
Yeah, so this is a very highly requested episode. It's been on the top of our list for quite some time, but we've been fortunate to have some amazing guests, so we never got down to sort of a deep dive topic. But today is that glorious day, and today we shall be talking about Dagger.
We're talking about knives?
Yeah, specialty knives.
Specialty knives. They are hand forged.
Exactly. When to use a butter knife, when to use a steak knife, when to use, I don't know too many knives.
When to use a Swiss Army knife. No, we're just kidding. We're talking about dependency injection today, which is, like you said, it's a very highly requested topic. It's something I've been talking about since 2005. Actually, the first presentation I ever gave in public was about dependency injection, and it was for the .NET framework at the time. Even back then, it was a very highly requested topic, and to this day, as each new technology seems to come out that does not have a dependency injector and eventually does have one, it seems that DI, also known as dependency injection, kind of comes to the forefront. And so today, we're going to kick it off.
So you bring up a good point. Usually when I've seen new Android developers talk about Dagger, the very first thing they think is like, oh, okay, it enables dependency injection. And that's not entirely true, though. Dependency injection is a fundamental principle in and of itself. And Dagger is actually a library that just like eliminates some boilerplate. But like the first impression that people think about when they think about Dagger is like, wow, I can do dependency injection inside my app only with Dagger. So I thought it might make a little sense to maybe just quickly give people a refresher on what dependency injection is in general and move on from there. Do you have like a sort of definition or something you want to throw out, Donn, for people to get dependency injections rooted in their minds?
Yeah, there's a couple of definitions out there. And essentially, dependency injection is basically the practice of passing in our objects, dependencies, collaborators, whatever you want to call it, into your object rather than creating them inside of your object. And so that's kind of a long way of basically saying, instead of saying, hey, I need to create a new, maybe let's say we have an API service that talks to a GitHub API, instead of saying, GitHub API equals new GitHub API right there inside of my code, I may actually have that instance passed into me through the constructor, and I set that equal to a field variable. And so I'm not responsible for actually building that dependency. I really don't care how it's built. I just know that I have an instance of it, and I expect that, that it's not null, but of course I should check for null, and that I can actually start working with it. So it's actually being given to me. So, and that could happen one of a few ways. The most common way, and the most recommended way is going to be setting the dependency through the constructor. Now, there are a couple of other ways out there, and we'll get to those in a second. But the constructor injection basically says when you create the object, in order to create it, this object needs a bunch of dependencies in order to do its job. And so in this case, it could be like I need a GitHub service, I need a person service, and maybe for some reason I need some other class that, or I need the string configuration variable for whatever reason in order for this class to do its job. And then that's passed into the constructor. And then at that point in time, the class can do its job. Does that sound about right to you, Kaushik?
Sounds perfect. that is the whole point. Dependency injection is actually a very simple concept. It's just a pattern where instead of like newing up a whole bunch of objects inside like the method that you're actually working on, you pass it in externally. So whether people realize it or not, you almost always have dependencies at play in your code. The only difference is, do you explicitly bring it from outside, or do you explicitly declare it in a way where it's immediately identifiable?
Yeah, and I think this is even apparent all over inside of just the, inside of Android itself, and stepping away from the topic of dependency injectors like Dagger, but actually just talking about the term dependency injection, providing a dependency to some type of class. You can take a look at just all the different kinds of views inside of Android, like text view, linear layout, all those different views. If you create a new one in code, what does it need? It always needs a context. And that is dependency injection right there. We are providing that context to that view. So we are providing that dependency to that view to enable it to do its job. It's not creating a new context. It's not getting it from singleton or from some application level variable. You're actually giving it the context that it needs to do its work.
Okay, so if you don't use dependency injection and go about with your regular wonderful life, you would probably have less boilerplate than you would if you explicitly use dependency injection. That's true, right? Dependency injection might be simple, but the problem is you have to explicitly provide the dependencies like inside your constructor or your method parameters, instead of just like using them directly inside your code, which means there is that slight additional boilerplate that's brought in. So that's a problem, right? So why should I still use dependency injection? Lesser code is good. Why do I need to go through the trouble of actually positioning my code so it allows for dependency injection?
That's a very good question. What's the point of even doing all this? It looks like there's just a bunch of extra work and I'm not getting any benefits out of it. And what I actually ended up doing was creating my own dependency injector. This is years ago, and it was a very rudimentary one, but basically it was just if you look at really rudimentary dependency injectors at the root level without them being too intelligent, they can technically just be a big map. And the map is just a key, and then it provides the instance that you're working for or looking for. Now, and that's the way that I developed it, because what I ended up finding out is at a higher level of the application, say the UI layer. So your application has 3 or 4 layers, and I need to talk to something down at the database. Well, then what I needed was something that could talk to the database that was the business, rules layer for whatever reason or whatever you're calling it, and then that needed to be exposed. Then you create the new instance of the business rules, and then, business rules for some reason needs these 3 or 4 dependencies to do its job. So then you have to create those new 3 or 4 dependencies, and then you realize those 3 or 4 dependencies each need a couple of things to do their job, and so forth. You could see how this just gets deeper and deeper and deeper. And eventually, just to create this simple little business rules layer or get an instance of it, you have, and I've seen this before, 15, 20 lines of code creating instances of everything that I need. And then that ends up getting replicated all throughout the application, because I may need that business rule in this screen, I mean in this screen. And so a dependency injector kind of comes in and helps us out in that regard, and saying, hey, well, looks like you need this entire object graph of things filled out in order to work with this object. The dependency injector will actually kind of build that object graph for you, give it to you when you need it, and then you can be off to the races and not have to worry about replicating that, 15, 20 lines of repetitive code that's technically very error prone as well.
You totally hit it on the nail there. Usually, so one of the reasons I became big with dependency injection was it allows testing, and that's also usually the sort of advantage most people mention with using a dependency injection, or even when you use Dagger. Like, point number 1 is usually, it helps with testing, and that is completely true. It makes testing super easy. But it's not just testing. The point that you mentioned, for example, if you want to create a more reusable sort of environment, if you want to have interchangeable, reusable modules, then that is one very big, huge reason to be using dependency injection. And that's, I think, a point that makes sense.
Definitely. I think the testing one, we should clarify too that it's not just a dependency injector too that makes your life easier for testing. It's the act of actually building your objects so that they are, given their dependencies through a constructor, because that enables you to test these things. And if you're using the inversion of control, and you're separating and you're passing in interfaces instead of passing in the actual concrete implementations, in testing, you can use tools like Mockito to set the expectations and the stubs and the mocks for those classes, those instances that you pass into your custom class that you've built, so you can actually simulate the various different environments that you could run into at runtime, which enables you to have a much easier testing experience. Because I'm sure we've all ran into the situation where, like, all right, well, I need to test this class. Oh, great. Now I need an internet connection. Oh, I also need a file system. Oh, I also need a database full of records. And then all of a sudden you've spent half the day or 2 days just getting the environment up just so you can write one test. If you're using inversion of control, you could say, hey, database layer, anytime someone asks for a person, go ahead and give them this mocked up person that we've just built. And it makes your life a whole lot easier.
It has to be pointed out that using dependency injection and possibly Dagger might make it seem like there's a lot of pain to begin with. Just setting it up, wiring up everything together properly might seem like a pain to deal with, but the benefits that it enables in the long term is just super huge. So almost always the answer is, well, should I bother re-architecting my application so it allows dependency injection? Almost always, 99% of the time, the answer is yes. It 100% makes sense to change it.
Yeah, and you also see this in very similar other industries, not like dependency injection, but you'll see that sometimes you need to do more work up front to realize the benefits later on. And one very simple example of this is cooking. If you're cooking, most of the professional cooks that you see will say, hey, look, you need to make sure that you have completely prepped everything. You've cut all of your vegetables. You have all your spices set up. You have everything ready to go. These are your dependencies, right? You have all this stuff, and then be building this object, which is maybe the dish that you're cooking. Now, when I'm cooking a dish and it's over a hot flame, I'm not going to be like, oh, I need some garlic. Well, things are cooking. Let me go chop some garlic real quick, and then I burn my meal. You're going to want to have everything set up together, and then you can kind of just toss stuff in there. So it's kind of one of those things that's a little more work up front, but the payoff at the end is 100-fold better.
That is a fantastic analogy. I'm going to use that. Do you do a lot of cooking?
I don't do a lot of cooking. I'm trying every day to get better at it, because I listened to a recent podcast, and this back in August, by Nabil Ravikant, I think his name is, on the Tim Ferriss podcast.
Ah, yes. I remember that episode. And
he had talked about, when you're cooking, if you cook at home and you learn how to cook properly, your food usually will taste better than in a restaurant. And I've been at people's houses where they can cook so well that it's just amazing, and there would be no reason to eat out if I could cook that well. So I am learning a lot more about it, and I've been kind of following different posts on Facebook and so forth. So hopefully we'll get there.
The next time I'm down there, you can prepare a good meal, and I can tell you how much progress you've been.
I'm really good at making cereal, dude.
Ah, there we go. Breakfast, lunch, dinner, solved.
That's right. I might even peel a banana. Banana. So there's a lot of computer science that kind of goes behind all this dependency injection stuff now, isn't there?
So when you think about the name Dagger, how did the name Dagger come up? So before that, gather around, let's talk about some computer science concepts. There's a common problem, and this is true even in real life. Back when you were in school, you know how there used to be like those introductory courses, like there's a Computer Science 101, 102, 103, and all those, a bunch of different courses. What if they had like certain dependencies between them? For example, in order to take the course 104, you had to make sure that you took the course 103. And in order to take the course 103, you have to make sure you take the course 102B. But instead, but if you had to take the course 104, you also had to satisfy this other course called 102 or A. So all of this gets like super complicated, right? To make it a little more simple, assuming you had like an object A and that depended on an object B, and object A also depended on this object C. Now, C, on the other hand, depended on this object D, and B, on the other hand, also depends on this object A. All this can get like quickly super confusing, right? What if there was an algorithm that sort of helped you map out this in terms of a graph? What if it said, okay, if you want to finish up and reach course 104, then you got to make sure you follow first course 101, then go to 102 A and B. Then you could do either one, 3 or 4, but because 4 depends on 2 and 1, you've actually satisfied the dependency. So you can go past and do 104. But 103, on the other hand, is required for 105. Or basically a problem of this end where you're trying to find the path to the end, making sure that the intermediate nodes are satisfied. How do you do this? So this is actually this is basically called deducing precedence. And the algorithm that you usually use in order to figure out or deduce this sort of order is called a topological sort. So this is like a well-known algorithm for people super interested. Essentially, what you have to do is a depth-first traversal of the graph, but you have to do it in reverse post order. Now, this might seem super interesting and people would want to know more, but we're not going to explain the details here because I'm probably sure Wikipedia or like one of those algorithm courses does a much better job explaining this. The reason I bring it up is because this sort works amazingly well in giving you the solution, but it only works on a specific data structure. It only works on graphs. Specifically, it only works on directed acyclic graphs. So if you had a cyclic graph, this would not work. A cyclic graph is basically where you have circular dependency. So if A depends on B, depends on C, and C again depends on A, boom, then that's gone. That's a cyclic graph. It won't work there. But if we had a directed acyclic graph, then this solution would work. Does that seem familiar? Directed acyclic graph.
D-A-G, DAG?
Slap on an ER at the end, and what do you have?
Dagger.
There we go. So in your application, you may have like a bunch of dependencies. I know Jesse Wilson, Jake Wharton, a couple of them, like some of the examples that they talk about are like the coffee maker, the filters, and all those things. Essentially, each object requires its dependencies. Internally, what they build is they build this graph, and that's called the object graph, which is very similar to this directed acyclic graph that we just talked about. So this object graph that you have, they run possibly, I'm not sure of the details, but I would imagine, because this is a very well-known algorithm, they would run something like a topological sort, figure out the dependencies, and that's how they do all the compile time checking and making sure, okay, so if I need dependency B here, if I need like a REST adapter for my retrofit interface, then in that case, let me do a sort and then see which of the other dependencies that I need before this. And then they step back, then they try to get those dependencies. And that's essentially how it works. So this is a very well laid out concept. And that's also how the name Dagger came up. All right, so I started on this long explanation on how Dagger possibly got its name from like the term directed acyclic graph and how a topological sort algorithm on a directed acyclic graph works. And possibly that's probably what Dagger was doing, but I've since learned from someone who's a little more knowledgeable with the intricacies of how Dagger works that is not the case. And in fact, it actually does something way more niftier than that. So without further ado, Jesse Wilson, thanks for doing this quick cameo.
Yeah, so it is definitely a directed acyclic graph in terms of how the dependencies are dependent upon. I'm gonna give you try and give you like a visual example. Imagine you're like writing Google Maps and you have a map renderer class and it needs a tile fetcher and a GPS looker upper or something, a GPS service. And then your tile fetcher also needs an HTTP client. Any HTTP client.
Clearly, I know which HTTP client I'll be using there.
Yeah, exactly. So the way that like Juice would work is it would be sort of like depth first, where the map renderer, when it's creating the dependency graph for that, it would look at the map renderer, look at its dependencies, look at the tile fetcher, look at its dependencies, and it would look at the tile fetcher's HTTP client, get that all wired together before it did anything with the GPS service. So it's start at the top of the graph, go to the deepest leaf, and then sort of like pop up and go back down very depth first. And so the way Dagger works is we wanted to avoid being recursive for a handful of reasons, some of which are like really stupid and cosmetic. Like when it crashes, what do the stack traces look like? If you're 11 dependencies deep in juice, the stack traces are just like enormous and insane. But the other thing is that we wanted to be able to have like a sort of like tighter control on the process of fetching dependencies. And so what Dagger does instead is it looks at the very sort of top level thing and it puts it in a queue. And so it puts the map renderer in a queue, and then it basically pops it the first thing off the queue and looks at its dependencies. And it says, hey, map renderer, configure your dependencies. And it's really optimistic, and it just sort of hopes that everything will work. And the map renderer dependency looks and it says, okay, give me my tile fetcher. And Dagger says, I don't have one. And it basically freaks out, and it puts a request in its queue. It says, I'm going to need a tile fetcher, and it queues that. And then it marks that the map renderer dependency failed, and it puts it back in the queue itself. And so actually it defers that. So it'll say, map renderer dependency is currently busted. And then map renderer will say, okay, I got my tile fetcher, and it didn't, but it will think it did. And it'll say, give me my next dependency. It'll say, here's your GPS service. And again, Dagger's like, oh, I thought I had one of those, but I don't. And so Dagger ends up in queuing both of map renderer's dependencies. And then that map renderer lookup completes. And Dagger says, okay, well, that was a complete waste of time. And it puts the map renderer at the back of the queue. And so now the structure of the queue is it says, okay, I need to look up the dependencies of this the tile fetcher and the GPS service. And then once those two are done, then it'll finally get back to the map renderer. And so the second time through, every dependency always succeeds. But the first time through, it always fails. And so if you look at like what order it visits everything in, it's like a completely crazy order. It's not an order that they teach you in any of your university CS classes. And the reason we did this is because if you look at the Dagger, like we're generating code to do all these lookups, and we could have like one method that says, tell me all your dependencies, and another method that says, basically take all of your dependencies. And we cut a corner and we have a single method called take all of your dependencies.
Okay.
And sometimes it doesn't actually give them back. And so we basically use the take method. It's called attach. It provides double service. So the first time it runs through, Dagger basically just remembers what the dependencies requested were, and the second time through, they are all actually available.
Nice. And I'll add a link to the show notes, because obviously Dagger is open source, and that's something that everyone can look at. The linker class is the one in question that I guess you mentioned.
Yeah, and it's really interesting. But what I also recommend is that if you're reading it, it's very dynamic. And what I recommend really doing is getting the linker class and like attaching source in, like attach the sources for Dagger in your Android Studio project, and then debug through and watch your dependencies get satisfied and like look at the queue. And once you know this trick, it's interesting. And hopefully what that means is that next time Dagger fails on you,
you know exactly what goes wrong.
Exactly.
Perfect.
Yeah. Cool.
All right. Thank you so much, Jesse.
All right. Bye.
Very, very interesting. I bet you most people don't know that.
Yeah, I mean, pretty cool stuff. Computer science can be useful sometimes.
Sometimes, yeah, right.
Yeah. Sometimes.
So we were talking about Dagger. I think that Dagger is an interesting, Dagger is a dependency injector, and Dagger is an interesting place right now because originally it came out as a library from Square, and recently it's been adopted by Google. So now we basically have two versions of Dagger out in the world, and we have Dagger 1 and Dagger 2. Now, which one are you using, Kaushik?
So I've used Dagger 1 and I still use Dagger 1. I don't use Dagger 2 as much. I've looked at it, at least I looked at it in the initial periods when it was still in this alpha period. I've not dived in as much as I would like with Dagger 2, so I've not used it as much. But Dagger 1 I've used a whole bunch.
I'm in the same boat. I've used more of Dagger 1. Just recently, I've hopped into Dagger 2 and implemented it on a couple of apps. But at the same token, I've had multiple conversations with a few Android devs that I know, and it seems that it's one of those things where Dagger 1 just still works. There's not a huge, for a lot of apps that were already built, there's not a lot of huge benefits or draw for them to rewrite a lot of their stuff to go to Dagger 2. And I think that's a completely valid point. And I think even Jake Wharton's U2020 app, which showcases Dagger and RxJava and a bunch of other stuff, it's still using Dagger 1. And it's one of those things like if it's not broke, then kind of don't fix it. Because there's some things that have changed from Dagger 1 to Dagger 2, and we'll kind of talk about some of those things today.
There might seem like there are some fundamental differences between Dagger 1 and 2. We kind of like try to sprinkle it as we go in with the rest of this episode.
Exactly. So let's hop into Dagger 1. Do you want to talk about the main parts of Dagger 1, and then I'll touch on parts of Dagger 2?
Sure. So whenever you think about implementing Dagger in your application, there are these pillar concepts, right? There are these fundamental things that you should just know, and that'll help you move forward. First is obviously this thing called the object graph. Now, we talked about like the topological sort and where this graph fits in. Dagger actually has this object called the object graph. And that's basically everything revolves around the object graph. All your dependencies are constructed and added into this graph. And anytime you want a dependency, you retrieve it from this object graph. Dagger literally calls this the object graph, so it makes it pretty straightforward. So usually what happens is in your application object, you would basically create this object graph. Now, along those same lines, we have the object graph. There are these two annotations with Dagger that are pretty huge in providing your dependencies. The first one is module. There's also this annotation that's called provides. So this is one thing I want to talk to you about. And like initially when I started out, it was a little confusing. And I realized it was confusing because many of these terms might seem very similar, but they can be fundamentally different. For example, there's this annotation provides, as I just mentioned. There's also this concept called a provider, which is actually very different with Dagger. Yep. So a lot of these things might seem pretty confusing. So what I would suggest is to really pin down and understand specifically what these terms mean, and then it just becomes much simpler. Mm-hmm. So talking about provides, what it basically does is you slap it on. We mentioned about this module class. Inside this module class, you can have certain methods. And the minute you annotate the method with the provides annotation, that basically says, hey, this is how you create this dependency. So Dagger will come to the module class because you've specified module. It'll understand that this class is going to provide you with some dependencies. And it looks at each method annotated with the provides annotation. So it understands that, okay, this is where I go to call the object. And that's how the object gets created. One fancy, super cool thing with the provides annotation is the methods that are annotated with provide. The parameters that you pass in for this method, Dagger automatically understands that, okay, these are the dependencies that are required for this object. So it steps back and then tries to find other modules that have provides methods for these dependencies that you have passed in as a parameter. So this whole combination between module and provides is basically how you establish the bindings for your application. The next important part is the annotation that almost everyone will start using once they have their application wired up, and that's the inject annotation. Mm-hmm. And this is pretty famous. The inject annotation is actually like an official JSR annotation, if I remember right.
Yeah, I think it is, yep.
I don't recall what it is, JSR 40, 30, something like that. But it is an official annotation that comes as part of like the Java X package. And this annotation inject is how you indicate where your dependencies have to be provided. So if you want to request a dependency, if you're inside your activity, if you're inside your fragment or any other class, you can slap on the inject annotation on a field, and that basically says, okay, hey, Dagger, I need this object, find this object for me. So it's the mechanism for requesting dependencies.
Yep. Now that's the Dagger 1 stuff. So if you are familiar with Dagger 1, working on a project with Dagger 1, that stuff's going to make sense. Now Dagger 2 has moved things around a little bit and kind of, from an outsider's perspective, in the name of scoping, from what I can tell, to allow you to have better control over your dependency scopes, meaning that you can create different scopes. And as Kaushik and I have talked about prior to the recording today, we were discussing why you may want to use a scope. And one of those reasons might be you're using the model view presenter pattern and you need a singleton that's kind of sitting atop all of these classes running, so you can perform some type of operations at a higher level just within the scope of that, of that screen itself. And then as soon as that screen goes away, you really don't need it around anymore. So that can kind of just go away. And so Dagger 2 helps with that. And now Dagger 2 has done that by basically getting rid of object graphs. So they are now called components. And this is exactly where the scoping can come into play. You can provide your own annotations at the top of these things, at the top of the components, and you could perhaps call it like the username screen component, and it has a certain scope called the username screen that helps Dagger manage the scope of that component and so forth. So the component allows you to do dependency injection and so forth. That's very similar to the object graph in that regard. All the rest of the fundamentals for Dagger 2 at a high level are very similar, almost close to the exact same, like the module and the provides. So the module class is the same, almost. The provides class is the same. The only difference in the couple differences in the module class in Dagger 2 is that the library setting, which we'll talk about in a second, is set to true by default, and it's by default false in Dagger 1. And there are no overrides in Dagger 2.
Oh, interesting. That I did not catch.
Yeah, so that's a big one. And at least it was the last time I looked a couple of weeks ago. And that means you can't override various injections for testing, which makes things difficult. There are workarounds for it. There's ways that they say you can create your scopes and things differently, but it's not as easy as it is in Dagger 1. And then, of course, the bindings and et cetera with the injections are the same as Dagger 1. Nothing has really changed in that regard. And as Kaushik said, we'll sprinkle that in through the rest of the conversation here. So I think we should talk about what's probably the most common thing you do in dependency injection, and that's kind of providing the dependencies.
So this is like a common flag that I've seen Dagger 2 getting. It seems like they've added one more object. So the components is something new. Everything exists. You have object graphs, you have your modules, like you cannot not do without them.
Mm-hmm.
But you also need this additional object called components. And they've also added more restrictions. So this is like a common point I've seen. Some people feel Dagger 2 is a little more restrictive. It's not as flexible as Dagger 1. And you also have like this additional object. Now, again, take anything I say with a grain of salt because I've not used Dagger 2 enough, so I may not be qualified to pass judgment. But that I have heard this sentiment. Do you feel the same?
Well, first, there is no object graph anymore in Dagger 2. It's gone.
Oh, okay. Fair
so
enough. Okay.
Components have replaced the object graph. And so you kind of have to view them as a very similar thing. Components just allow you to implement the scoping using annotations and so forth. So that's more powerful in that regard. However, on the flip side of the coin, I do agree with you. I do feel like I'm stuffed into a box when I'm working with Dagger 2. I don't feel like I have the flexibility to do what I want. And now there are reasons. Again, other things have been done in Dagger 2. Basically, they're trying to eliminate as much of the reflection as possible to really speed this up. And some sacrifices were made in order to do that. I don't think I found a consensus on the web about what people think. A lot of people say, I'm sticking with Dagger 1. A lot of people say, oh, I like Dagger 2, I'm going with that. It kind of feels like the Python 2, Python 3 dilemma, you know?
True. Oh, that makes complete sense now, actually. That's not too bad. Okay, so they got rid of object graphs, at least like from the API level, and they use components instead. That makes a lot more sense. Yeah,
for example, if you have, I think it's object graph, you can just provide the inject annotation. I think that's what it was. It's like the annotation, the inject method. You could inject various different things inside of your activity that way. And a component is also very similar. You just get access to the component that you call the inject method on it. Now, there is one thing that's different here that I am not a huge fan of. You can inject inside of the base class, but you also have to perform the injection in the actual class that you're doing as well. Does that make sense?
Oh, yeah. But, okay.
And from what I found, that's the only way. You have to do it this way because of the way Dagger 2 works. And I'm not sure of the exact reason. I'll have to do a little dig into it and do a little more research and maybe put it in the show notes for everybody. But it has to do with something the way that the Dagger 2 and I think the reflection and so forth, or lack of it.
So in order, because they don't have reflection to sort of make up for that, they try this kind of approach.
Yeah. Speaking of which, we should plan on getting Jesse Wilson or some of the guys from Square on here to really give us a deep dive into the internals of Dagger. That would be pretty cool in the future.
Yeah, absolutely. Once we have this episode out and people have a base understanding and they come in with great questions, we can pull one of those folks in and be enlightened. All right. So you mentioned providing dependencies. Let's talk about providing dependencies. So I mentioned the two annotations, modules and provides. So this is module, the annotation module, and provides, ES, the annotation provides. Module is a class where you sort of indicate how to provide your dependencies. I talked about this. A typical example is a lot of people use retrofit, right? So in order to wire up retrofit, you need the OK HTTP client, you need a retrofit adapter, you need your REST adapter, and a whole bunch of things. So one way you could typically do that is create this class that just takes care of all your network dependencies and call it your network module. So you can create your network module. And this is very typical. If you see any examples on GitHub, they follow the same pattern. They have maybe a network module, and inside that network module, they'll provide the dependencies required for all network related activity.
I do a very similar thing for Android stuff. I'll have just an Android module. So anything that's provided by the Android system, I'll just kind of throw inside of there that I need.
Oh, nice. So your application object and that kind of stuff.
Yeah,
Context.
Default shared, context, default shared preferences, Wi-Fi manager, anything that calls get system service, I'll just kind of wire it up. Anything that I need Android to do for me, I'll just kind of throw into the Android module for my apps.
Nice. Speaking of that, speaking about examples, the U2020 app by Jake Wharton is a fantastic example where he gives you this, he has the boilerplate code ready for wiring up Dagger with a bunch of the libraries that Jake has made. So that's an excellent example. We'll obviously point to that in the show notes. So Donn, how do you want to quickly take us through how you actually create this module class?
Yeah, no problem at all. So a module class essentially is just a file. It's just a Java object, and you're going to create this Java object on it's a class. And typical nomenclature is end it with the word module. So as Kaushik said, if you want to create something that's specific to networking, you may call it network module. And what you're going to want to do is at the top of the class, at the class declaration, you want to add the @module annotation onto the class. And so that basically says, hey, Dagger, this is a module, a Dagger module that where you can find all of the bindings to, for all the dependencies. So this is how you're going to create all these dependencies that all the other classes in the application are going to be asking for. Now, inside of the module, you need to actually be able to tell Dagger, here's how you create these instances of these objects that I need. And let's say use the example where I'm going to have a GitHub service, and that's going to use retrofit underneath the hood or whatever, some REST adapter. I could go inside of there and create a method that returns a REST adapter. And this is a retrofit thing. Turns a retrofit REST adapter in there. And then in order for that to be picked up by Dagger, I need to slap the @provides annotation onto that method. Now, the nomenclature for those methods can really be anything you want, but from what I've seen in the field, it's either been provide and then whatever it is. So if it's going to be REST adapter, say provide REST adapter will be the method name, or provides. It depends on the team and how you want to, if you want singular or plural words. And basically, this tells Dagger, hey, anytime that you need someone asks for a REST adapter, here is how you're going to build it and give it back to them. Now, this is also interesting because anytime you build a provider, this is a binding of some sort. Sometimes you need other instances of stuff. So I may need a HTTP interceptor, an error interceptor that I've built for retrofit, and that may need to be provided somewhere else. And so I may have another method in that file that also has the provides annotation slapped on it, saying, hey, anytime someone needs this error interceptor for this REST adapter, here's how you build it. And that may not require anything additional for it. And so what happens is when Dagger looks at this, it says, hey, someone needs a REST adapter. Cool. And then inside of the method parameters, I'm basically saying, hey, in order for this method to work, I need this error interceptor. And then what immediately Dagger does, oh, well, let me go see if I have that. And then it kind of looks through the modules and says, oh, if it can find it, which in case it does, we've built that method at this point to return the error interceptor. It'll go to that method, say, hey, okay, give me the error interceptor. I'm going to shove it into this method so I can build the REST adapter, so I can give the REST adapter to whoever's asking for it. Now, the cool thing about Dagger is that a lot of this is compile time generated code. So if for some reason I don't provide the implementation of that error interceptor for some weird reason, what will happen is Dagger will say, hey, I can't find, it'll give you a compilation error, basically saying, hey, I can't find anywhere where I can build a error interceptor. I don't know how to build that. And then at that point, it's kind of a error message to you like, oops, I forgot to implement that inside of my module or one of my modules. And so you can have multiple modules, and we'll talk about how you can kind of include them here in a second. But that's basically how you build a provider to provide a binding for a dependency. Let's talk about the includes one first in the includes module. I was previously just talking about, I had mentioned that Dagger will look inside of the modules to see if it can find a place where a particular binding may be found, like that error interceptor. Maybe I've decided to put all my error handling stuff inside of an error handling module for whatever reason. And the network module does not have it in there. And so what ends up happening is basically Dagger says, I can't find it. And then what you can do if you have another module and you would like to include it inside of the module declaration, you say, hey, this includes another module as well. And so I can actually include my error handling module. And that will actually, when Dagger then starts looking for the dependency, it'll actually look inside of that module as well, saying, oh, yes, I found that error interceptor in this other module. I'll go ahead and shove it into this REST adapter thing, and now I can build my REST adapter and I'm happy.
Makes perfect sense. Right at the beginning of the show, we mentioned that one of the things that Dagger helps with, besides testing, is reusable and sort of interchangeable modules. And this is basically a big way you can do that. You can have a whole bunch of modules and reuse them using this includes attribute in the other modules that you have.
Yeah, and this is huge for when there are certain things in your app or even across multiple apps or anything in that regard where you need to share that code. Very common situations are you need to provide certain JSON serializers or deserializers that you don't want to replicate all over the place.
The next one is, and this was pretty confusing to me initially in the initial days, and it's the injects attribute. Now again, this is different. This injects is an attribute inside the module annotation. We're not talking about the inject annotation. This injects, at least in Dagger 1, basically tells the module, hey, these are the different points in my application where you could potentially be asked for a dependency. And the reason we do that is because it tries to do this compile time check. And that's why it's important to mention in each of these modules where the potential target locations would be for these dependencies. Is that like a fair summary of the injects annotation?
Yeah, it's like you're just like I like to say the wording that I use is this is basically any place where I can do injection in the app. I'll put it in here. And for simpler apps, I've seen modules like the root module will use injects, and then I've called it before entry point module, and I treat those as entry points for the injector. And so inside of the injects, you pass in the array of things, and that's going to be the activities and the fragments and the services and anything like that where I may be doing my injection. Which brings up a good point. where do you normally, where is your root level of injection? And in traditional Java class or program, it's going to be in, main. That's where you're going to do the injection, and that's where the entry point of the dependency injector hops in. Now, Android, we don't have that ability because we're an Android and we don't have constructors and activities and fragments. So the entry points are basically going to be the high-level UI components, such as the activities, fragments, services, receivers, stuff like that.
Mm-hmm. That's basically the point where you say, hey, give me my dependencies, right? That's where you kick off the dependencies.
It's where you're telling Dagger, in Dagger 1, you're saying, hey, object graph, I want you to inject this activity. And then it says, hey, I need that user service that does something with some users, and that user service needs that REST adapter we just talked about. And then that Dagger then builds that entire object graph and just gives you that little user service for you to do your job.
Okay, so I talked about the injects attribute. So if you don't have this location or this target location specified, Dagger will fail on you. It will say, hey, I can't understand this. But there are certain instances where you don't necessarily need the injects attribute. There are special cases. And that's where the next attribute comes in, which is library. Can you take us through that one?
Yeah. So now let's say that we have a module that's there, and it's there only to satisfy other modules' dependencies. And this goes back to the perfect example of my Android module. This is where I put a lot of the common stuff. It provides a context. I can provide shared preferences, Wi-Fi managers, package info, all that kind of stuff. Now, a lot of times, some of those things won't even be used or are needed or not even going to be used inside of the current module itself, or maybe not used in the app, but it's there if I need it. And so let's say one of my classes needed something from that class at all. So what I could do is I could just slap the library equals true inside of the module declaration here. And so I don't need to provide the injects because it's not injecting anything here. So the injects is completely out of the picture at this point, basically saying, hey, this module should be treated as a library, as a module library, that it can perform work as a library. It knows how to provide common things that other modules might be interested in.
That, I guess, is like the key there. You don't necessarily have injects because these things like the shared preferences that you mentioned are not directly injected into a location, but this module is included as part of another module. We mentioned the includes attribute. So another module, like a more front-facing module, might include this module. And so because of that, if you how do you go past that? Like if you don't have the injects annotation, it's going to fail. So the way you go past that is you mark it as a library. So saying it is a library means that, oh, this is potentially going to be included in another module. And once you do that, you can go past this restriction. There's actually a very nice Stack Overflow answer that Jake responded to. So the question was, this person basically was like, I don't want to use the injects directive. Is there a way I can go past this? Like I have this problem, basically explaining the reason that we just mentioned. And Jake basically points out the same thing that we mentioned. I'll add a link to that in the show notes. It was interesting.
Definitely. Now, I mean, that kind of brings up the next important item inside of the modules is, like we said before, sometimes a module has everything that it needs to build its pieces, and sometimes it doesn't. And you kind of have to tell Dagger about that, don't you, Kaushik?
So there's this next attribute that's basically called complete. So you can say complete false or complete true. In your module, you might have we mentioned the provides annotations, right? So you can have different methods saying provides. Now, these methods have parameters, as we mentioned, and those parameters are basically telling Dagger, hey, in order to create this object that's returned by this method, I need certain other external dependencies. And these parameters are those external dependencies. Now, what Dagger can do is basically, it's going to, as it does this compile time check, it's going to look around the whole graph and it's going to try to find this dependency. If it doesn't find this dependency, it is going to fail on you again, as it rightfully should. But sometimes there are cases where you don't necessarily want Dagger to fail on you. You can basically say, hey, you know what? I got this. Don't check this specific method. I know what I'm doing here. Does that make, is that like a fair reasoning?
Yeah, No, I think you pretty much nailed it there. I really don't have much to add.
Cool. Just to do a quick recap, Donn, you mentioned that in Dagger 2, some of these were defaults. Like now that we've talked about these attributes, what were the defaults again?
By default in Dagger 1, library is set to false. It's now set to true in Dagger 2. And then there's a new one that we haven't talked about yet. Well, not a new one. It's an existing option inside of the modules, and that's called overrides. And in Dagger 1, overrides basically is, well, let's talk about it backwards here a little bit. If in Dagger you provide two implementations of, let's say you have an interface, right, and it's customer service, and you provide two methods that return customer service. What Dagger basically does is it looks at the graph, using the algorithm that Kaushik talked about earlier, and says, hey, I have two, you're asking for a customer service, but there's two different methods that build the same thing. I don't know what to do. And it basically blows up at compilation. Now, the way to get around that is you can mark the module as overrides, and this is very common inside of a testing. You may have something in your testing code path that says, hey, we are going to override this module. Maybe it connects to some really slow DB2 database, and you say override it and provide fake DB2 database, and it just does some mocking and stuff like that. You just provide the overrides equal true inside the module declaration, and then at that point, Dagger hops in and says, hey, I found two of these, customer services, whatever, and then it says, oh, I'm in the test code path right now. I'm using this module. It says to override the original one, so I'm going to go ahead and take that one over the one that was provided before, which is, maybe the production one. And so that's usually the use case of that. Now in Dagger 2, that has changed. That has basically changed a lot. Override is not supported anymore. It's gone. So there is a workaround, and we'll add this link to the show notes here, but I'm actually going to read directly from Pierre, who's from Square. He replied on the Dagger Google group, and I'm just going to read his reply because it actually it's very succinct and makes a lot of sense. And he basically said someone was coming up with a problem saying, hey, how do I deal with this? And he says, override isn't supported anymore. Component interfaces are how you do these kind of things. Remember, components we talked about are basically the replacement of for object graphs, and there's component interfaces which provide you with the scoping and so forth. So let's say you have a backend component and it needs a listening, executing service for whatever reason. You need to create another component that will provide it, like a service component. Now, that service component would provide that listening, executing service that the backend component needs. At that point, service component provides that stuff to the backend component. Then what you would do is you'd create a fake service component and have it extend service component. And at runtime, you would give the fake service component to the backend component. So it would actually be indirectly using the fake one, but it's basically relying on an abstraction to get around the overrides. And that's kind of how the overrides work. So Dagger 2 not there, Dagger 1 they are there. So that's kind of, it's a big sticking point for a lot of people. Not a lot of examples out there right now on it, but or a lot of people that have said, hey, I'm not moving to Dagger 2 until this is fixed or this is changed. So a lot of apprehension on that.
Yeah, it makes sense. Like a big part of my testing strategy, my UI testing strategy with Espresso, and we'll talk about this a little later, is to be able to provide these sort of test modules where I'm sort of mocking out certain aspects. And without the overrides, that would be pretty hard for me. But I guess, like you said, there's this disclaimer, so I should probably go and read that and look at this component interface thing.
Yeah, definitely. There's it allows for scoping, and so it's useful. There's a lot of uses in it. It's, what it is. I felt like I had to change the way I was thinking about how Dagger was building the object graph, kind of like orthogonal a little bit.
Yeah, makes sense. Which is not necessarily a bad thing. It's just different.
Different, exactly.
Okay, so there's this other big concept that Dagger doesn't allow, which is called assisted injection. Now, let's talk about what assisted injection is. There are certain times where when you're asking for a dependency, there are two inputs. One is basically another dependency from the graph, but you can also sometimes, you may feel the need to pass in runtime parameters. So let's talk about a specific example. Say you have an image downloader service object. And this image downloader service object, like some of the parameters that it requires is like the networking stack. So you need like an HTTP client, possibly like an executor object on the image downloader. And these are provided by the graph itself. So these dependencies, we already know at the time of constructing the graph how these are provided. But maybe as a user, sometimes you want to point to different image services. So you can say Imagely, or use this URL for Imagely, use this URL for, I don't know, Jiffy or some other weird image service. So these are runtime provided. So there are many use cases where people feel, well, okay, take all the existing dependencies that the graph provides, but also use this parameter. I'm giving you just this one attribute. Use this attribute, and then you'll know how to move forward with everything, and everything's good in the world. This is basically what you call assisted injection, where you're telling the graph, hey, I'm assisting you with some additional parameters, construct the dependency using this. Dagger does not allow this. And if I remember correctly, even Dagger 2 doesn't allow this, right?
Yes, from what I know, it's all the same fundamentals apply.
Yeah, so this is this concept called assisted injection. There are some amazing threads. Jesse Wilson came up, again, Jesse Wilson talks about in detail in this Google group thread. We'll add a link to that in the show notes. Because basically people asked for this, how do you do assisted injection? And there was a lot of talk about maybe adding it even in the days of Dagger 1, but right up until this point, it hasn't come up. There's this other gentleman who goes by the name Christian Gruber. He's also a big name in whenever you go and see some of these Stack Overflow answers on Dagger, he weighs in with some amazing answers. I don't recall exactly where, but in some thread he mentions that today, if you really do want assisted injection, the way to do that is using this library that Google maintains called AutoFactory. Along the same lines, the concept of maybe qualifying or giving additional information to your graph, right? So there's this annotation called qualifier. Can you take us through that one?
Yeah, sometimes when you need a particular dependency injected, you may have multiple versions of the same thing. And usually Dagger will complain about this unless you're providing some type of qualifier for it. So again, we could do the whole override thing if we wanted to override a particular item in Dagger 1, or we could do the extension thing and components for Dagger 2. But let's say for some reason we do need to return 2 of the same thing for a particular reason. Now this happens in various instances in Android development. And one instance that I've run into it and many times is a lot of times applications, you'll like to abstract away the user and application settings. So perhaps the user has set some certain settings and you want to save that in a preferences file. When you first start out with Android, you'll just shove everything into the default shared preferences. And then eventually you'll realize that's completely unwieldy and too hard to deal with because you're just worrying about editing and committing and applying and all that kind of junk. So you'll end up refactoring the shared preferences behind some abstraction like application settings, which is just a class that allows you to set certain things on an object. Now, inside of app settings, you will have inside of there, you can pass in the shared preferences that you may use to use as the backing store for that. You may also have another class called user settings, which also takes shared preferences. But you don't want to use the same shared preferences for each of them because you don't want to pollute these files and again, create this huge unwieldy beast. What you can do is use a qualifier, and for example, you can use the @named qualifier. This is the one I use all the time, and you can pass in a name of this preference. So I may be providing a shared preference object and in a module, and I'll call it application preferences, and I'll use the @named qualifier. And so what will happen is anytime I've asked for to inject a @named shared preferences with the name of application preferences, that's the one that will be returned. Now I may also return shared preferences in the same module a little bit lower, but that one might be called user preferences, and that's qualified with the @named preference as well. So it allows me to create and utilize 2 different, shared preferences files and, abstract them into different application classes in itself. So it makes it a little bit easier to get different versions. Now I know you've done it different. You've had some stuff like this at Wedding Party. What did you do?
Oh, yeah. So a wedding party, as folks might remember, is a service where you upload photos and share photos for your wedding. Now, we basically had 2 backend servers. One was like the traditional AWS stuff where we have like our application logic. So like user information about your wedding, etc., all these things. when we wanted to store our photos like that the users took, we didn't store it on the same architecture. What we would do is we would use S3. So basically, Amazon has these two very different services. S3, which is where S3 is like a perfect place for uploading pictures, files, and storing all that kind of stuff. And AWS is where like our application server exists. Now, when we used retrofit, so whenever you wanted to upload information to one of these servers, we would call for a retrofit REST adapter. I would use like the same qualifier annotation. So if I was uploading a picture, then I would have this qualifying annotation called like image server. So I would slap that onto one of my REST adapter providers. And so when I ask for the dependency for my REST adapter, if it finds this qualifying annotation called image server, then I basically know that, hey, the REST adapter that I'm looking for is the one specific to uploading images onto S3. So that was one way that we used this at Wedding Party. So and this is why I said it's similar to assisted injection, but it actually isn't assisted injection in that it doesn't pick anything from runtime. You already have these qualifier annotations declared, and at the different points in your application where you want the same type of object. So like you said, like if I wanted shared preferences, but I want to add just a little more information to it where it's not the generic default shared preferences, but it's my application shared preferences, or it's my user shared preferences. And the same thing with the server example that I gave as the S3 server, not the AWS server. So that's the way we use that.
It's so hard to explain this stuff on a podcast sometimes.
I know. This might seem like complete gibberish, but if you have it like in code, it would seem so immediately obvious.
Yeah, if you're watching a screencast of this, it would make a lot of sense. Explaining this level of detail, explaining code over an audible form is difficult, but hopefully we're giving you a few
there
hooks.
was a place you could make screencasts. Sigh. Folks should check out Caster.io. That was my indirect sort of kick towards. It's an amazing service that Donn's been using, and he's uploaded some videos recently there. So definitely go and have a look at that.
Thank you.
We've talked, I guess, of like the fundamental concepts and tenets of Dagger specifically, and I guess at this point people should have a good idea. There are these other concepts that come in play as well. So knowing what we've just mentioned should get you through almost 80 or 90% of the way with Dagger. Again, a lot of this may not make sense just hearing it on the audio, which is why actually what I would suggest is people first try out Dagger, run into the problems, be confused, and then come and listen to this podcast. And then when you listen to our examples and as we describe each of these sort of attributes, it might make a whole lot more sense. Okay, and the last concept, and this is like super huge, and this is something that I've looked for a lot, at least when I started out with Dagger. And Donn, maybe you can throw some light on this, is Espresso. With Espresso testing, how do I inject custom test modules? Because that's the whole point, right? Like the reason we're going through all of this trouble is to make testing easier. Not just unit testing, but also UI testing, right? So how do you do your mock module stuff in Espresso?
From the way that I understand it, that you do it, I do it a very similar way. I don't even know if I could really even call it any differences. I create different modules for things that I need to override. And this was in Dagger 1 because I haven't gone into any testing implementation in Dagger 2 yet, so I can't say how well the subclassing the components works yet, but that supposedly should work. But in Dagger 1, I overrode anything that I needed to use, and that would be inside of perhaps the testing code paths. And I would say, all right, well, in this case, I don't want to hit the endpoint, or I do want to return a mock web server for an HTTP endpoint, return this JSON and so forth. And so I'd set that up in the before test, the before annotation you slap onto a JUnit test, and would set it up inside of there. I think that's the same way that you do it. Am I correct too?
Yeah, no, that makes perfect sense. So when you create this graph, as we mentioned, the way to create your object graph is to provide the list of modules. The trick basically is you make sure that your application recognizes also the test modules that you set in your test. And this was one thing that it took me a long time to figure out, and it's actually pretty easy now. With Espresso now, there's the test rule, the activity test rule that makes it super helpful to sort of kick off your test in Espresso. The activity test rule, when you create an instance of this object, there are certain parameters that you can pass in. So the first is obviously the name of the activity class that you send in. The second is this thing called touch mode. You typically want this true, like that's a whole different topic. We're not going to go into that. But more importantly, the third parameter in this activity test rule is this Boolean flag, which basically says, hey, should I launch my activity or not? By default, it's true. So when you create this activity test rule, the minute you start up your test, it'll just like pop it up. What I do is I create this activity test rule with the flag false. So basically, it doesn't launch the activity. I run through the setup method as you mentioned in the with the before annotation. That process is exactly the same. I set in my test modules there, and in my actual test, when I'm actually in the test, that's when I take this activity test rule and I call launch and provide the intent. So that's when it really kicks off the test. And so then the object graph creation at that point, when it starts creating the graph, it already, because in my before method, I've set up these test modules and I haven't actually begun my application just yet, it recognizes that these test modules also have to be added in. I guess it's almost exactly the same the way we do it.
We should try to see if eventually we can get some type of code sample up. I think that'd be very helpful to a lot of people. So we're not guaranteeing it this episode, but we'll see what we can get though.
All right. It's that time of the episode where we give listeners some awesome picks. So why don't you kick it off here, Donn?
Definitely. So first, as Kaushik said, I do some videos at caster.io, and there are some free videos, a bunch of free videos up there. Recently released some free videos on how to get started with RxJava for Android developers, kind of walk you through replacing an asynchronous task. Also show you how to use Realm for data persistence. It's an object store. It's super nice. You don't have to write SQL anymore, which is totally awesome. I'm not a big fan of SQLite, so check it out. It's really nice to get going. And then lastly, inside of for the caster videos, I actually have a whole series, and that's unfortunately not one of the free ones, but it's actually on Dagger 1. I'll be creating a new series on Dagger 2. So if you're looking for a deeper dive, walkthrough, probably about an hour in content, there's like a 5-part Dagger 1 series on caster.io.
It's a good thing you mentioned this at the end of the show. If it was at the beginning, they're like, oh, okay, skip this episode, just watch the videos and boom.
Exactly, right? Exactly. So then next one is custom molded earbuds. This is something that's interesting. I've been interested in for a while. I would like, you can basically take this putty and custom mold your ear and put your earbud into it, and you can slice it so you have these custom fitted earbuds that fit your ear perfectly and are very comfortable, don't give you headaches or anything like that. So there's a link on howtogeek.com. There's a few of these links out there. Instructables has them and so forth. So definitely check that out. I'm heard a lot of good things about it. I'll probably be doing it here very shortly, and I've done a lot of research into it. And lastly, there is an article that was just released in the last couple of days by DHH, he is the creator of Rails, David Hannemeyer Hansen, and he has a blog post called Reconsider, and it basically talks about Silicon Valley, the life of startups, what it means to be a startup, and maybe it's time to reconsider if what you're doing is right for you, because are you in it for the right reasons? And so it's just a good kind of life post to just read and help you reconnect. That's it for me. What about you?
Nice. There's this person who goes with the GitHub handle Dreaming in Code ZH. They gave a very nice trick to sort of improve the start time of your application. So it's almost like an illusion where they basically mess with the background. And as you specify the background when you pull up the application, it makes it look like your app actually starts a little faster. We'll add a link to this in the show notes. They also have these GIF-like pictures in the GitHub project, and it clearly shows the illusion and how it seems like your application will start faster. I thought this was a pretty clever trick. The second is not related to development, but this is actually another podcast that I follow, like this podcast called Song Explorer. It's an amazing podcast where they basically take these different tunes and construct it. 2 episodes of note. One, he takes the Game of Thrones soundtrack, and the other is the House of Cards soundtrack. They take both of these soundtracks and they he talks to the actual people who created these tunes and explains like the different inspiration behind coming up with these tunes. I thought it was amazing. I listened to this podcast very ritually. It's amazing. So people should definitely listen to that. All right. You can find the show notes for this episode at fragmentedpodcast.com/episodes/21. If you have feedback or suggestions for us, please feel free to add your comments right at the show notes, or you can use Twitter and shoot either Donn or me a tweet. You can find Donn at Donn Felker, that's 2 N's, or his website, donnfelker.com. You can find me on Twitter at Kaushik Gopal, or my site is kaush.co. Thank you so much for listening, and we will catch you folks next week.
Banana.